Well, thank you, Jason, for hosting this Friday afternoon webinar. This is my second webinar today. The first one was at 4 p.m. in Europe, and so I've had some nice training this morning. So this one will be even better. Yeah, actually, the last time I did this webinar, I asked some people ahead of time, you know, what do you use EthoVision for? Well, obviously, as most of you will know, most users will use it for mice and rats, tracking mice and rats, rodents. But as it turns out, the list of creatures that people told me about was quite extensive, from the very small, like Daphnia, to the much larger animals like pigs. Unless, of course, this is a giant squid. In that case, that's the biggest one. Moving on to, yeah, I'll briefly introduce myself. My name is Wieland van Giesen. What do I do? Like Jason said, I'm involved in technical support and help out people with their experiments, remote and on-site installations, trainings, webinars, user meetings. And yes, I am coming to you today from the southern part of the Appalachian Mountains in Asheville, North Carolina. This is our skyline. And this is actually the Biltmore. It's the largest house in North America, supposedly. And my own history, well, I got my master's in entomology from Wageningen University from the Netherlands. As you can tell from my accent, that's where I'm from. In fact, this is where Lucas Noldus got his PhD as well. So we go way back. I saw him put together the Observer 1.0. Then I did a stint at a USDA lab in Charleston, South Carolina, and Clemson for 8 years. And yes, in fact, I need to update this. I have been with Noldus 21 years, 17 years in sales, and 4 years in support. But it's not about me, it's about EthoVision. What are we going to be talking about today? Well, before we get into all kinds of analysis features, we need to make a couple of stops along experiment setup. Let's focus on a few things like manual scoring, a little bit underused, I think, and the all-important trial list. Then we dive right into all those profiles. What are data profiles, analysis profiles, and especially what can you do with the combination of the two to obtain your statistics and charts. And then obviously you need to optimize your data so you can export it to, you know, potentially to Excel. And while you're there, you can make all kinds of interesting pivot tables. I'll show you some of that. I've had people more happy with pivot table info than with the whole EthoVision training in the past. Then we'll address the charts, the always popular heat maps, and the visualization of your data. And here I am really hoping I'm preaching to the choir, backing up and restoring, very important. And in fact, we need to also talk about post-tracking analysis without the need of a hardware key. That's sometimes unknown by users. Then we'll look at custom templates so you can achieve, you know, maximum experiment consistency. That sounds good. And then I'll show you guys, you know, where to get all kinds of help in your documentation, videos, etc. And then I'm going to briefly check on whether everybody's using the latest version they're entitled to. Are you up to date? And that allows me to introduce our new portal called My Noldus. I'll show you how to do that setup. And then finally, we're still living in COVID-19 times, and we put something together so people can use EthoVision remotely if you can possibly work from home and still do some work. So that's kind of the overview. Now, in order to show all kinds of features and things to do in EthoVision, I came up with kind of a standard experiment. Now, I know that not everybody in this audience is studying mice and rats, but it is a rodent example called an open field test that is for measuring anxiety. The whole point here is that the rodent is inside a box. you make two zones in EthoVision, the center and the periphery, and you keep track of how much time the animal spends in the center, because that would mean it's less anxious. Otherwise, it would stay around the walls. And on top of that, we're going to use a couple of different variables to make it interesting, to make it into a more real experiment, treatment, genotype, day, etc. So, well, off we go. The first part of setup I want to point out is manual scoring. This is a very handy thing to do. EthoVision is supposed to allow you to do everything automatically, which is great. But sometimes there's a need to add some behaviors you're interested in. So you can add those here, assign them to your keyboard. Let me put my pointer on here, my laser pointer. So you can attach these behaviors to your keyboard, and you can then score your behaviors and add those. Now, in the past, you would have to do that live. Nowadays, and that's since version 13, you can actually do all of that coding, behavioral coding, at your leisure after tracking using manual scoring under acquisition. So in effect, you don't even need the key for that. That's kind of a loophole. So you can score by hand. You can go in slow motion, go back and forth. You can do it. You can go completely overboard with the coding scheme if you desire to do so. Of course, the whole point, is to eventually not need it anymore if you need to validate some parameters in EthoVision. Now, the examples I've just had in that for example may not have been the best ones because it's grooming and rearing. You can actually do that with a module that we actually have for that called the behavior recognition module. So this is a plug for that. This is the whole list of behaviors you can use for that. Now, the standard things we have to do to set up an experiment, everybody will be familiar with this. You have to set up an arena. You can create different zone groups here. We create that center zone and the periphery because that's what we want to study. And, you can make it more interesting. You can divide it up in different zones as well. So we have two independent zone groups. Moving on to trial control settings. Here, most of you will be familiar with the standard sequence. You decide when tracking starts, then this condition has to become true for it to stop. So this is a very simple 5-minute trial. But, you can add a few things. This is a lot of, you can add through custom hardware, you can, after 1 minute delay, have a light come on, and then after 30 seconds delay, have the light go off. And on top of that, maybe after a 2-minute delay, a sound comes on, 30 delay, sound goes off. Now, that is not part of your standard package. For that, I'm plugging that again, I guess. Your trial and hardware control module for optogenetics, for fear conditioning, etc. Now, this is really important, the trial list. I've seen plenty of people, I do tech support, so I see a lot of people, well, not a lot of people. Every now and then you come across people who send you backup files of their experiment and they haven't used the trial list at all. Now, that's not illegal, but it sure is handy for experimental design and export, and in fact, making data profiles and analysis profiles. So for instance, you can add your user-defined variable day if your experiment lasts across multiple days, or you want to keep track of your animals, animal ID. Maybe you want to keep track of genotype, and now you can actually predefine those values to keep it more consistent. Another example would be treatment. That's an obvious example. Control versus treated. And now, during experiments, things do go wrong. Every now and then, let's say in this trial number 3, your animal is sick or jumps out of the maze, or something goes wrong and you can't really use it. Now, you can right-click and delete it, but then later you would have these weird holes in your data. So it can be a good idea to just add a column, call that use for analysis, and add, have ones for all the ones that went okay, and a 0 for when things do not match up. So later in Excel or further downstream in your statistical analysis package, you can easily filter out those zeros. Another handy thing to do could be, you know, a column for comments, so you can actually you know, show why that became a zero. And you know, all these columns here are going to be exported alongside Excel to Excel. So the more you put in here, the more organized you may be. So that's that. Yeah, so here we go with data profiles. What are data profiles? Well, there are, you can do that different ways. You can filter your data by selecting and grouping complete tracks, or actually select part of tracks, and that will be called nesting, like only a certain time period, or only when the animal is in a particular zone, or only when it's moving. And then finally, you can also make time bins, where you can chop up your whole recording in time bins of a certain duration and analyze it per bin. So let's look at all those three versions. So first, filtering. Now, you know, this is how every data profile begins, and I guess you could call this data profile, if you don't do anything, you can call that all data. You can rename your data profile and call this all data, because everything that you collected, 40 tracks, are also showing up in your result container, and that will be exposed to all the parameters that you select under your analysis profiles. We'll be talking about that next. So here, let's say you want to group all your treated or your control animals together. Well, these are the ones that I just added to my try list. So now I select treatment. There you go. Treatment, control, it gets added. And now I have a filter box, and I went from 40 tracks to just 20 tracks. Very important in this case too, and if you forget everything I tell you today, hopefully you won't forget this one. You need to rename that result container, because otherwise, once you export it, it'll say results 1, 2, 3, etc. But it should be have a name, so you want to rename it to, in this case, control and treated. So, and each has now 20 complete tracks. Very good. So, but these are two groups of complete tracks now selected. Now we move on to nesting. So this, what I just did was filtering. Now we move on to nesting. Now we, for instance, want to know, okay, I want to calculate the mean velocity when the animal was in a particular zone. So it's only in that zone part of the time. That's why it's going to be a partial track. So the next thing is you click here on in zone, select the zone you're interested in this case, that center zone for this open field experiment. And there you have it. So now instead of 40 complete tracks, we actually have 40 partial tracks. So only when the animal was in the center, I'm going to expose that to the parameters that will come up in my analysis profile. And again, you know, well, you want to rename that, so I'll call that while in center. And then, of course, you want to repeat the same thing for when the animal is in the periphery. So that was nesting. Now we move on to time bins, and you don't pick that up anywhere under filtering or nesting. That's actually, and we go there for the third time now. Go to settings, and you click on the box for results per time bin. You indicate how many seconds it needs to be, or minutes, depending on your experiment, of course, and ignore the last one if it's not exactly, in this case, 15 seconds. So that's how you chop it up in time bins. Now we move on to analysis profiles. We just went through our data profiles. Now it's moving down to analysis profiles. This is where you indeed pick all the parameters of the statistics you want to throw at all of these data profiles you just created. So, for instance, I want to know how often an animal goes into a zone, how much time it spends in there. And So you click on this box, and there it is. And this is the way it looks for all of these parameters. You get a tab that is specific for that parameter. In this case, you want to pick zones. In this case, the center and the periphery again. Then the next tab over is body points. Of course, that only shows up if you have the module that tracks nose point, center, and tail base, the multiple body point module. The next tab over is statistics. There's a lot of them, and you pick the ones you need. So how often did they go into a zone, the total time spent in there, and the time until the first time going into that zone. So you can create a whole list of the parameters that you need. And again, you can have multiple analysis profiles, just like you can have multiple data profiles. And now that you have created both of those, now you can actually put them together. So for instance, I pick the data profile all data, which will show up where it always is on the left, but also across the top. And we select all parameters. And that means, all data and all the movement parameters. So that's one way to analyze it. Now you can change it, here's another example. Now I selected per treatment in 15-second bins. So see, that's control and time bins. And I'm selecting different zones, center and periphery. And now they're divided that way. That's a great way to get a lot of data in a hurry using time bins. Now, there's an extra tab that I'd like to point out now. If I click here on Group Statistics and Charts, then it creates a neat little chart. In this case, Stigmotaxis, the tendency to be the frequency along the center in the center point. Now, this is all descriptive statistics. You see error bars here. That's standard error. It's not like this is a NOVA. For that, you still need to export all your statistics to Excel, and that's where we're headed next, I think. Yeah, export. So you pick the right combinations of data profiles and analysis profiles, and now you click on Export Data. However, and right now, it only shows me, trial 1, 2, 3, 4, 5, 6. And what you do not see in here is all those variables I created, like genotype and treatment and animal ID and all of that. In earlier versions, you would see them now already in the next, nowadays, in the latest 2 versions of EthoVision, since new in 14, you have to click on the layout button and actually select the ones you want. So in this case, like I said, day, genotype, animal ID, and treatment, and you click on that arrow, and now it shows up here on rows, and the end result is all of this. And now you can click on export, because you need those variables in Excel and further downstream in your statistical analysis as well. So here we go. You click on export. You browse to the folder where you want to export it to. Make sure you select Excel. If you want, you can also select text files. And very important, make sure this checkbox is checked. Merge column headers, because as you can tell here at the top, the header above each column is comprised of 4 rows, and you really just want 1 row once you get to Excel. So that's where we are now. And as you can see, it is in 1 row. Although now that we're in Excel, it's very hard to read. There's a couple of things you want to do once you get here to make it more usable. So the first thing you want to do is format the top row. So this is the top row. So what you do is you just, change the color a little bit, align it the way you want it, click on wrap text, and widen the top row a little bit. So there you have it. And the next step would be, in fact, there's something you notice now. There's this gap here. There's no data above those columns. That's unfortunate. Those are not exported, so it's up to you to quickly go in and type those in yourself. Don't forget to do that because it's pretty important. So the next step is to highlight all your columns here and go to Insert and then Pivot Table. Now, some of you may use them all the time. Others will have never used these, may have never heard of these. So if I click on Pivot Table, okay, what is the range? The columns A through AR in this case. And that's all you have to do here because it's going to automatically, by default, add it to a new worksheet. So if I hit OK here, then see here at the bottom, the pivot table is a separate tab from the one we just had, is your data sheet. And there they are. Let me see, let me click on this. There's treatment, genotype, ID. You get sick and tired of these. The same show up here again. And now it's up to you to distribute these in the right boxes here at the bottom, because that's how your pivot table will come out. So here we have here average distance moved for control versus treated, for knockout versus wild type animals. Once you and again, this is not an ANOVA, this is not statistical analysis, it's just to get an overview of your data. And in fact, the next step could be to insert a graph, which will use your pivot table. So there you have it, so control versus treated, knockout, wild type, total distance moved. So now you can rearrange it any way you want. So if I now, let's say, swap genotype and treatment, then it'll look like this. So the next thing I want to go to is visualization. First of all, charts. We saw some of that already. Group statistics and charts. So this is another way to look at your data. Here we have another example of a combination of data profile here during light and sound. Remember in that example earlier on, we were going to have the light go on and the sound go on in the cage with your animal. And now we click on the group statistics and charts, and out pops our graph. And again, standard error, not statistical analysis. And so then you can export these graphs. See, oh, here we go, light on, sound on, and your zones clearly. The next step is track visualization. This is the track of all your animals on top of a still image. You can have multiples. And how do you organize that? Well, what you want to do is click on Show Hide here at the bottom right, bottom top right. And again, you get that same layout window, and you want to select the two variables you want to use, put them in there, and then it looks like this. So you got treated and control, knockout versus wild type, and again, you can export that to export those images for posters, presentations, etc. And of course, you can manipulate all those columns as colors as well. Lots to play with here. Another way to visualize your data are heat maps. Turns out to be very popular. Let's say here we have, and again, this is the same way you organized your visualization. You go to the layout section once again, click on results and day, and again, it's organized a certain way, and then it's ready for export and use in your posters and presentations. There's one more visualization, is the integrated visualization. This is where you can actually play back your video with the track superimposed on your video. And in this case, it's all data and movement, and it will play back and it moves over your graph. So this is a great way to see what all goes on simultaneously, and whether or not the track is indeed always on top of your animal as it should be. Good way to review your data. So this is another example. See, here we have during light and sound and all parameters. And as you can see now, parts of this are grayed out because it's only showing the data for when the lights were on. And again, that's what exactly will happen in your analysis, in your numbers as well, in your data output. Okay, now we need to talk about, like I said, I'm hoping that I'm preaching to the choir, but because it is important to make backups of all your data. You don't want to just leave it on the main EthoVision computer in the animal room or wherever you have your setup. What you want to do on a regular basis is click on in the file menu, select make backup. Very important. And you browse to the folder where you want to save it. And it's optionally you can include or not include the actual media files that were recorded at the same time as you were tracking. And of course, that can lead to pretty large size files. It's a zip file of everything. And so now you can save that EVZ file on a flash drive or on the network or an external hard drive, and then take it to another computer on which you install EthoVision. You can install EthoVision on every computer you'd like. And then you click on Restore Backup, navigate to your EVZ file, and now it opens up on that other computer for maybe post-tracking analysis. Speaking of which, the use of the hardware key. Now, most of you will probably run your experiments in a special area, like in an animal room, where you have all your cameras and your mazes or your setups, a PC with EthoVision, obviously, and this is where data acquisition is being done. And for that, of course, you need the USB hardware key, the dongle. Now, you can also have a PC with EthoVision installed in your lab, in your office, or at home, especially now with COVID-19. And if you want to do post-tracking analysis, so this is all after you record your videos and your tracks, you do not need that hardware key. And I keep running, since, like I said, I'm doing tech support, so I keep running into people who are not aware of this and think they need the key for everything. Of course, everybody who's listening right now knows this, but there's just always a couple. So what you want to do is create such an EVZ file, a backup file, and bring it home or to the office in the lab. And that will free up the space for maybe someone else to do more experiments. And, actually will do data acquisition with the key. The only exception to that is if you are tracking from video files and you want to do that in the office or in the lab or at home, then of course that is data acquisition, and then you do need the hardware key again. So hopefully that workflow is clear to everybody. Another thing is the use of custom templates to make sure you have some consistency across multiple, successive experiments, especially if it's a longitudinal study. So, because, experiments contain a lot of settings and, you don't want to have to redo that every time. So obviously you can open an old experiment and throw out all your data, but the system can do it for you. So in this case, instead of creating a completely new experiment, you select New from Template. Then you have two options. The first one is indeed using the Noldus supplied predefined templates for mostly rodent experiments. But in this case, what I would suggest you do is use a custom template. And that basically means selecting the experiment you did last month because you want to use it now with all the same settings. So you select that older experiment, and obviously it wants you to get a new name. You don't want to override anything. So a new name, and it now spits out a new experiment with a new name with the data removed. And you can obviously you want to tweak that experiment because your arena may have shifted a little bit, or things like that. new animal IDs, etc. Okay, now I want to speak a little bit about the online help, all the help features that we have built in, quite a few. So the first thing I want to point out is the online help. In the help menu, you can actually click on EthoVision XT help, and it opens up basically kind of a website looking interface, and you can browse around and look, you can search for certain things. Let's say you want to learn more about heat maps, it's all in there. Then we have a couple of PDFs available. The first one is the PDF version of the online help that I just showed you. All 1169 pages, so it's pretty extensive. But then we also have a quick start guide, which is 23 pages, which is more readable, I suppose, and in 5 languages. It's a good introduction to new EthoVision users if you get them into your lab. And for the people among us who use EthoVision for rodent studies, we have the so-called application manual. Super handy. It has 12 chapters, each about a specific test and the specific settings for the open field, all the way down to optogenetics experiments. So also very handy. Make sure you download that as well and print out maybe the sections that you're interested in. We also have bunches of video tutorials. In fact, on the front page here and in the help menu, you can go and click on the video tutorial, and my good colleague Andrew Spink will pop up and narrates a 90-minute tutorial video about how to use EthoVision. Basically what I'm doing right now, but then with a nicer British accent than this weird Dutch accent. But anyway, you can click through it for the different sections. And on top of that, when you are in a particular part of the program, like let's say in data profiles, then there is also a section here where you can click on, and it starts a context-sensitive video tutorial just about, in this case, data profiles. That you find that all over the place. Super handy. Now, what I've been using here for this, that's the latest version of EthoVision is 15.0.1418. And to find out which version you are using right now, you plug in your hardware key and start it up, and it actually tells you which version you are using. However, in an earlier, ahead of an earlier webinar, I actually asked people which version they are using right now, and I then looked them up in our database, and it turns out 30% of these people were reporting an older version than they were entitled to. And that's a shame, because we keep adding new features and improving our software, see, from 9 through 15. So you want to maybe check on that by going to My Noldus, which is, is a good moment to introduce you to My Noldus, which is our new portal. If you now go to the Noldus website, then there is a new feature, a new option at the top called My Noldus. And when you log in, then you can get access to all your licenses. This is for users and co-users, and it'll tell you exactly what you have. In this case, this person has version 14. And if in the lab it turns out they're running 13, then you need to download the new version. And where do you do that? Well, you go to the software and documentation section, download the software now, along with all the PDFs and online help, the PDFs, the quick start guide, etc. And it's not just the latest version you can download, also the older versions. So not just 15, but also 14, 13, and 12. If you happen to have 11 or you need 11, then we can send you a link for that. Of course, you have to register for My Noldus first. If you don't have that yet, you can create a new account there. You need a registration code. Some of you will have received that code. If you don't have that code, then click here on this link here, and it generates a request that comes to us for such a registration code, and then you have access to everything. Yeah, now finally, you know, we're still, for the time being, not everybody can go to the lab. So if possible, if people have lots of videos or can do post-tracking analysis, then we have a little document about the remote use of EthoVision. Of course, you can use it with or without the hardware key. If some people can take the hardware key home. The other option would be to access EthoVision by connecting to your work PC back in the lab. So if you're interested in more information about this, let us know and we send you the PDF for all of that. And basically that, you know, that's my presentation. That all I had to tell you about EthoVision and how to analyze your data and export it all, etc. There's a short webinar, a short survey afterwards. Please fill it in. We'd love to hear from you. And well, I bet, Jason, there have been a couple of questions being added to the chat box. So let's see,
There are indeed. So thank you very much, Wieland. And so first of all, yes, this recording is going to be made available. So Wieland, I'll let you handle the question. So what is the difference between an EthoVision backup file and copying the original file folder to an external hard drive?
Well, you can copy it all to an external hard drive. It's just that it's more error prone. It is all self-contained. It puts all the folders in the right place when you restore it. Now, there's nothing wrong with it because it is basically making a zip file of that same folder. You know, there's nothing magical about it. It's a zip file of everything. If people do it that way and it serves them well, then I'm not going to argue. It's just that it's a convenient way of moving your data around and for safekeeping and moving it to other computers.
Great. So another question is there a way for EthoVision to count the number of behaviors an individual performs, such as the number of times an animal moves faster than a certain velocity?
Yes, you would have to put that in your trial control thing that triggers a counter every time it goes above a certain speed, and then later that counter can be, you can find that counter in your data. Yes.
Yeah, and just thinking also, you can use the dichotomized variable of movement, and then you could say the number of times the animal moves faster than X velocity, and if it does that, count it as moving, and then you would be able to get the frequency of the movement as well.
Yep,
So
that works too.
Like you said, Wieland, or
right. Multiple ways of doing it.
All right, so here I have a specific question regarding detection settings. I have several different sized animals and my detection settings need to change over trials. Each time I make detection settings, it overrides the previous one. Is there a way to have several different detection settings concurrently in one experiment?
Yes, this is a typical tech support question sometimes. Let's say you've made a detection settings for animal A, and it works great for animal A. Tracking is great. Now you get to the next one, and things don't work well. Now you seem to be stuck because all the settings in the original detection settings are grayed out. They are saved. So the next thing you want to do is right-click in the Explorer on the left. Right-click on the detection setting, duplicate it, and now tweak it for the next setup, your next animal. So yeah, you can end up with a whole bunch of detection settings. Of course, what you want to achieve is the even lighting and everything constantly the same, so you can stick with just the one detection setting. It saves you a lot of time later. But that's not always achievable, obviously. That depends on your setup. Hopefully that answers that question. Jason, anything to add to that?
It says, yes, that's what I tried, but it keeps updating the settings.
It keeps updating the settings. You know what? Let's talk about that. Feel free to contact support, and we can talk about your specific settings, because I'm curious to learn what's going on in that case.
Agreed.
Yeah.
Okay, another question for you, Wieland. When EthoVision provides values for missed and interpolated samples, is there a way to further sort by zones created in an arena to determine the amount or percent of missed interpolated samples per zone?
Yeah, you can divide it up, select zones in your in a data profile, and then you get the number of missed samples for each zone. As far as I know, you can get all of that per zone. Yeah.
I know in the analysis profile, if you select distance traveled and then you select the statistics, you can get the number of samples. And so then it will also give you the number of samples collected as well.
Exactly.
Okay, one more question, then the question and answer. How can we split files belonging to different treatments in different folders while we are using the same experimental setup? For example, the same light-dark challenge test used for treatment A, treatment B, etc. How can I organize my data into different folders for ease of use?
Different folders. The first thing that comes to mind is some alarm bells going off for moving things in different folders post-tracking. That's probably not what you want to do. You want to keep everything contained in separate experiments and just launch a different experiment for different groups, or make an additional variable, I think, in your trial list when you switch from one group to another, and keep it organized that way. You know, like group A, group B, group C. But they may be referring to something slightly different. So again, feel free to contact us with that more specific question.
Okay, moving to a few questions here in the chat for you, Wieland. Can you access EthoVision through a VPN?
Yeah, we do have people that remotely access. In fact, I had that on the screen, I think. Let's see if, where's, oops. At least, yeah. Did I have it on here? No. I guess that's explained further down in the utility to access EthoVision on that PC. So yes, that's possible. We'd be happy to send you the documentation to explain exactly how that works.
Okay, so we have a couple of questions. Well, hold on, I'll answer one first. Can EthoVision use to track multiple animals in the same arena?
Absolutely. That's the one module I did not mention during my webinar. That is this a plant? Maybe it is a plant. It's the social interaction module, where you can track multiple animals in the same space interacting with each other, in order to make sure that you know who's who throughout the recording. You would have to use a color camera and color mark your animals if possible, which is not to say you cannot use unmarked animals, but then the number of parameters you can extract from that is more limited. Hopefully that answers that question.
Okay, we have two questions about updating. So if we update the software, will we lose information analyzed with previous versions? Let's say we have version 12 to get 15. Do we have to go through 13, 14, and 15, or can we go directly to 15?
From 12, you can go to 15. If it goes to 7 or 8, then I would have my doubts. Then you would have to skip to an intermediate version first. But yeah, we always suggest that people make backup files in the older version, the original version, and keep those safe. And then you can completely open up experiments in the new version. It automatically becomes an experiment in that new version. making those backup files earlier is the reason for that is that you cannot now open up the newer experiment back in the older version. So it's not backward compatible in that sense. So you have to keep your workflow pretty clear so you don't get into trouble. Make backup files first.
And then related to that, a question I missed earlier, will updating EthoVision change anything previously done? I guess that's kind of a similar question. Will all the data be automatically updated?
Yes, yes. When it opens up in a new version, everything is automatically updated for that new version. Of course, sometimes that new version has new bells and whistles, and you can maybe now make, for instance, heat maps, or you can yeah, you can do more manual coding all of a sudden because that was not in earlier versions. So, so yeah.
But I also know that you can have multiple versions, and as long as you don't, the software is not backwards compatible. So as long as you don't open up that experiment with the new version, you can continue to have experiments in version 13, say while you're finishing up a project. And then a lab mate can be running a new experiment with version 15 without any issues.
That's right. Yeah, because some labs have multiple users, you know, and you want to finish up a project in one version before you make the leap to the next one. Yes.
Okay, and we have a comment that says that you can digitally mark different animals in the social interaction module. This works best when animals don't crawl over each other, when the digital marks might accidentally get exchanged. Yes, absolutely. Okay, quick couple of more questions coming in on the Q&A. I create an arena in a place where the animal was not there. How come I had results on that empty arena?
Huh. Well, it probably found the next best thing in that arena, the darkest area or the lightest area, and so yeah, it looks like you've got data points in there, but it's it probably doesn't move much, but it's unless there's dust bunnies running around in there. Then yeah, so that can happen, right?
And is there a way to program different length inter trial intervals in one experiment? Say 5 minutes in between trials 1 to 5 and 10 minutes thereafter.
If you do that in sequence, then yeah, you can only set one interval as far as I know. And it would have to be the same one. Don't you agree, Jason? That's.
I think unless you had different trial control settings.
Well, yeah, but if this is the batch mode where you go one after the other, the inter-trial interval, you can only set one inter-trial variable, as far as I know.
Mm-hmm. That's right. In the acquisition, you can only set one inter-trial interval, but if you set them in the trial control settings, if you have the trial and hardware control module, you can do it. But I think
yeah, but that's within one.
D-line is absolutely right. Follow up on the update question. Do you not recommend updating in the middle of a large cohort experiment? What could be impacted?
Well, this is more of a gut instinct thing that you don't want to change horses in the middle of a race, you know, especially it just makes, you know, you want to be as consistent as possible there. Now, if you finish, if it's a study that goes over years and you have to repeat it next year, then maybe in between you can upgrade to the next version. Yeah, basically you do that when you're comfortable with it. That's what it kind of boils down to. But yeah, not within one experiment. That's I would stick with the same version.
Yeah,
you know.
Absolutely.
Yeah.
Okay, a couple more questions. Just upgraded to version 15, but we kept our black and white camera. What would be the value of upgrading the camera?
Well, if you can still track all your animals the way you did before, if you're talking about having an analog camera from the earlier version, then there are some advantages of switching to our new Basler camera. It's a high resolution, so you would have more pixels at your disposal, so you could put more maybe more arenas under the same camera, things like that. And it's just clearer and yeah. But if you're doing a water maze experiment, for instance, then that same animal that you're tracking, you need to get total distance moved and things like that, then that's not going to be any different with the newer camera. So, right.
All right. How do you delete tracks?
Well, yeah, in your try list, you can right-click on the left side of your in your try list and actually delete the track. Of course, now there will be a gap. You know, it'll say trial 1, 2, 3, 4, and then 5 is missing, and then it says 6. So that's why I was a big fan of introducing that new column for marking tracks that are no good, and keep them, you know, kind of keep track of them that way. But yeah, if you need if you want to delete them, then you can do that.
All right, I have one more, which I think is more of a suggestion. Would you consider doing a model-specific tutorial just for zebrafish, for example?
Yeah,
that is an excellent idea.
That is a great idea, and I think we should work on one. Yes, absolutely. You know, to be determined. You know, watch this space, I suppose, and it'll be in the list of webinars, upcoming webinars.
Yeah, absolutely. Well, I think, Wieland, you answered all questions. I really appreciate everyone's engagement. Some really, really great questions. Again, as a reminder, the recording will be sent out along with a quick survey asking for some feedback. Let me see if we have any last questions. Nope.
Yeah, we'd love feedback. We always want to.
We're using version 14. We don't think we can delete trials. You should be able to in the trial list. So just give Wieland a call. And he'll fix you right.
Yeah, talk to me. Come on. Yes.
You got time for one more, Wieland?
Oh, absolutely. Yeah.
All right.
We're all here now, so you know.
Regarding the velocity of movement in the open field, do we have to set the different velocities ourselves, or does the software provide different velocities, high or low, for mice?
Well, you get data for velocity. It's going to give you a number for velocity, mean velocity, maximum velocity. You don't actually set a velocity. Yeah. I guess you can analyze velocity per time bin if that's handy. Jason, is that how you?
Yeah, and I mean, obviously for the movement parameter, yes, you would have to set those different velocities yourself. By default, I think it's set to moving when over 2 centimeters per second, and then not moving when I think it's 1.75.
Right. But that's like an on.
You could use your minimum and maximum and look at your integrated visualization and make your determination from there.
Right. Then it becomes an on-off state. You're either moving or you're not moving.
Or not.
That's right. Yeah.
Absolutely.
And not moving is not exactly 0. There's actually a lower threshold that is above 0 for not moving. You know, it's that's how it works.
All right. Well, thank you again, everyone. I wish you all a wonderful, wonderful weekend.
Yes.
For those of us in Cincinnati, happy remote. Cheers to a remote Oktoberfest, since we can't celebrate in person.
Oh, everybody drinking at home? Oh, yeah.
Yeah, so please, again, feel free to please give us some feedback. Really appreciate everyone commenting on the zebrafish, and we'll look into that. And with that, thank you again. I'm going to stop the recording.